If I pointed to something over there, but it appeared over there, then that's an example of spatial unpredictability.
We'll see how we can use this information in just a second.
Jeff Hawkins once said that prediction isn't just one of the things the brain does. It is the primary function of the neocortex, the foundation of intelligence. So how can we use this innate ability of the human brain to better suit how our learners memorize things and therefore how they perform? Well, let's have a look.
So the Penn principles currently state that spatial predictability guides attention. Psychologically speaking, if a shifting visual object appears in the same location or surrounded by the same visual information over time, then learners will be quicker to locate and attend to it. Educationally speaking, comprehension and memorization is improved when attentional cues are used to highlight relevant information. And neurologically speaking, the ability to predict where a word, object, or image appears decreases the amount of neural resources required to identify and process it. So there are a few questions that still remain from this original Penn research. Let's look at how the assigned seating in a classroom or training session might affect the learning. In what ways can we apply this concept of spatial predictability in vocational training? There are numerous studies surrounding the best seating arrangements for different classroom activities. Depending on the types of sessions being run, preferences were shown for horseshoe, circular, and round table. Additionally, a 2019 study found that the proximity to the facilitator affected the learning, finding that obviously the closer you are, the better in general. This has a flow-on impact in virtual classrooms, where every seat is the same proximity to the facilitator. Or small workplace learning, where the students are usually gathered around the instructor. In this video though, we are considering using assigned seating throughout a session and its effect on retention, at least as far as how this relates to spatial predictability. We will discover in another video the value of context when learning. But for now, why do we choose to sit in the same seat every time we go back into a classroom? And while not everyone chooses the same chair every time, I'm sure that you've attended a class in the past where you've noticed this little phenomenon. The reason, according to the University of Victoria psychology professor Robert Guilford, is that we create a safe place where our learning can continue from one session to the next. He says most of the time, most people claim a space and others tacitly agree to it. Upsetting that safe space can lead to unnecessary cognitive load and emotional effects that will usually impede a learner's performance. So the general rule is leave your students to choose their own space. Intentionally changing the seating can have advantages though. If the intent is to disrupt the student's way of thinking about a subject, such as disruptive problem-solving activities or critical thinking tasks and so on. But this should be done with immense care, ensuring the reasons are explained to your group members and the move to a different environment is smooth. This is known as the transition, and we'll talk more about this in a moment. Ways to use spatial predictability. The existing position on the matter is that the learner's memory is improved when a visual cue, such as an image on a slide or an object in the room, is used to anchor their attention. So when new content is added to a session, you move predictably from the existing visual cue to the next. Why? Because their brains are doing less work and therefore they have the room to take in new information into their working memory. Let's have a look at a spatial test now for you. You'll be shown 5 words and try to remember them. Are you ready? Now write down or repeat the words you remember to yourself. How did you go? Now let's do this again with the following words. Are you ready? Again, repeat the words to yourself or write them down. How did you go that time? More importantly, what did you notice? What did you notice about the ability to recall the words? Was it harder the second time? Let's do one more. Are you ready? Okay, now say the words back to yourself. So how did you go? What difference did you notice between this test and the first one? Firstly, just to let you know, colour has very little impact on spatial memory. What did occur with the first use of colour was that it was not expected, and therefore produced a slight recalibration of expectations in your brain. This did have a slight impact the first time around, but only as a distraction. Let's look at the results. You may have noticed though, in the last test, the temporal differences, or the differences in the timing of when each word was displayed. Researchers found that temporal change has less effect when spatial predictions are consistent. So in this case, the words still appeared where you would expect them. And thanks to the previous changes in colour in test 2, you were probably less affected by that feature. Chances are, you remembered the words in test 1 and test 3 better than you did test 2. If your results were different, what do you think was happening for you? Some considerations are distractions external to the test, attentional variations, so that your focus wasn't as intense from one test to the next, and possibly you just have a working memory that's outside the standard bell curve. So let's see how we transfer this to the learning environment. Research of younger learners found that 3 key elements must exist to improve the transition between subjects or concepts. Number 1 is to explain the transition before you do it. 2 is to model those behaviours of what the transitions will look like. And 3, allow practice with feedback. The process of transitioning itself becomes a learned predictable behaviour and therefore maximises learning time. Another study found that explaining processes before they occur not only improves predictability, but gains the trust of learners at an unconscious level. When you demonstrate a skill or task, the consideration of spatial predictability should lead you to 2 behaviours. 1, allowing the learners to position themselves in a space that they're comfortable with, and 2, explain the transition from one task to the next in a smooth and predictable fashion. You can even ask your learners what they expect to happen next, and when you do it right, their answers should be encouraging to you. Lastly, when your learners are practicing their skills, there are 2 things to remember. 1, only interrupt them if there's a safety concern. Interruptions can take their attention away from the task, and this distraction impedes learning at the unconscious level. They may be working through steps, so their brains are expecting a predictable outcome at the start and end of each step. An interruption breaks that cognitive process. And 2, we will learn about context-dependent effects in a later video, but suffice to say, practice should be encouraged in environments that are safe, predictable, and close to real environments.